As mentioned earlier, Python's built-in Unitas library can automatically discover and run all test cases, display all test results at once, and provide detailed information for failed tests, greatly improving the efficiency of unit testing. In addition to the commonly used AssertEqual, the test case class provides many other assertion methods. For example, AssertTrue works like AssertValue is true, and AssertIn works like AssertItem in container. These methods also have corresponding negated versions, such as AssertNotEqual, which is similar to AssertValue1 equals value2, and AssertFalse, which checks that a value is false. In principle, AssertTrue can replace all of these methods. For example, both of these tests check whether 2 is not in the list, 1, 2, and they produce the same pass or fail result. However, it's still recommended to use more specific methods. For instance, if you want to test that an element is not in a list, use AssertNotin instead of the generic AssertTrue. This is because more specific assertion methods provide clearer and more informative failure messages when a test fails. Sometimes, we can further improve testing efficiency by using additional techniques. For example, when testing a class, we need to create an instance in order to call its method. Since each test case is independent, we often need to create new objects repeatedly when testing different methods. To reduce unnecessary repetition, we can use the setup method provided by the test case class. Before each test method, those whose names start with test the setup method is executed once. This way, we can create the test object once in setup, store it as an attribute of the test class, and then access it in each test method. Now it's time for practice. Suppose we have already written a shopping list class. It includes these methods. First, the constructor method, it assigns the shopping listy attribute to the passed-in dictionary. The dictionary contains item names and their corresponding prices, just like this example. Then, the getAppamCounter method returns how many items are in the shopping list. The getTotalPrices returns the total price of all items in the shopping list. To write a test program for this class, first create a new file. You can name it starting with soytest for example. For test shopping list, to use the Unitist, to use the Unitistsb library to help us test. Write an import statement to include it, then also import the class. To be tested, from file name import class name. Now, we can officially start writing the tests. Create a new class. Make it inherit from the FoyTestCase class. In the FoyTestCase class, in the Unitist library, we can first test the suitd key. NiTeamCount method, note that methods must start with suitest to be automatically recognized as test cases by Unitist. Suppose we have a shopping list, like this. It contains these two paper 8, a hat 30, and slippers 15. If we call the fidesugate item counter method of the Su shopping list, it should return 3 to us because there are 3 items, so we can write shoyself. AssertEqual, then the value returned by WiGetTotalCount equals 3 next. Test the favende TotalPrice method. We can still use the same shopping list after calling the FidoTotalPrice method. The correct value it returns to us should be equal to how much is it. It should be 53, so we still use the FidoUseDself. AssertEqual, method passing the number 53 as the second argument. But here you can see we are actually repeatedly creating this test object, so we can consider using the number 53 as a tupFA. Method note that its name should be exactly the same as here. Then inside, we can create an attribute, for example, called ForShoppingWirelisty. This name can be chosen arbitrarily. The attribute name isn't important next. All places that use the specially created Teventi shopping listy, we can modify them accordingly. Here there is an error. It says the variable folding listu does not exist. We need to use WeToonDself. Shopping when listy here. That is its attribute, this place, FuVinself. Shopping list, now we can run it. To see open the terminal, we enter the test command, which is Python Munitist here. It says 2 test cases were run, and the test result is 2 dots indicating both test cases passed. If we intentionally change the number to a wrong one and run the same command again, then we can see one of the dots becomes an IFIN. Which one did not pass? It shows us the method that failed the test. Then below, we can see it even points us to the line where the test failed. It also tells us the reason the test failed is that 53 does not equal 55. That is the first argument, its value is 53. and the second is 55. They are not equal, so through unit testing we can confirm whether the program behaves as expected after making changes to the original code. We can also use unit testing to verify that the parts we don't want to be affected still execute as expected. See you in the next video, which is essentially about this shopping list object.